Hello and welcome to the Oklahoma Aquarium. My name is Dr. Ann Money and I'm here to talk to you today about coral biofluorescence. So our tank talk for today is here in front of our live coral exhibit. It's mixed coral, which means hard coral and soft coral. One of the things that we study here at this aquarium is biofluorescence in coral and how it can help to mitigate or help some of the damage that's happening out at sea for coral. Unfortunately, oceans are getting hotter, and that's really hard on the coral. We've lost about 50% of our coral around the world. To point out why that's so important, coral reefs make up about 0.1% of the ocean, so not very much. However, they are home to 25% of all marine life. So they're extremely important for those of us who like to eat fish, for medicines, for tourism. They are worth trillions of dollars every year. Plus, they are one of the most diverse habitats in the world. So what is biofluorescence? Well, I think it's pretty cool. It's where things glow. So people that talk about bioluminescence, like a firefly, this is different. It also produces light, but it uses a different mechanism to do it. So if you look over here, this is a fluorescing coral. So we can happen to see that with our eyes. So within the wavelength of light that our eyes can process. Most of the coral in here glow that bright or brighter. We just can't see it. We need special lights and filters to be able to capture it. So this is a blue light right here, and this excites the proteins that cause the fluorescence. And then this yellow filter helps to block out that blue light, so all you're left seeing is that brilliant, bright glow. So there are many, many different colors of fluorescence. What we look at here is green fluorescence. So green fluorescent proteins produce this light, produce this color. So we thought about it. We thought, well, what is it for? Why do these coral fluoresce? Well, one of the reasons is the same reason that we fluoresce. And yes, we do, as does a million things around us that we just can't see. But it's a natural sunscreen. So UV light from the sun, it hits our body, and instead of hurting our tissues, it's absorbed by that protein and then re-released as light, as that fluorescence. So that's one thing. It's a natural sunscreen, which is very important for coral. But the other thing that we looked at here at the aquarium is, were there some other uses for it? And there are. So there's a little algae that lives inside of the coral, and it's how they get most of their nutrients and energy is from those little algae through their photosynthesis. So converting sunlight to energy. Well, sometimes when the ocean gets really hot, the corals spit out that algae. And so they're losing most of the energy and nutrients that they receive. So they have to attract algae back to them. They have to repopulate the inside of their bodies with these algae. So what we discovered here at the aquarium was that fluorescence was actually like a beacon or an attractant for that algae to come back to the coral. And this is so important because when the water heats up, when we have what are called bleaching events, which is when a lot of coral turn white because they lose that algae, they can get that algae back and survive. So that's really important for us as humans and super important for the animals in the ocean.